So one of the side projects I have been building out just for fun is something called Agent System Swarm, which allows me to hook into my GitHub repos. And whenever I leave a comment with a particular command, it can run any of these agents that I've defined. So for example, I have a malicious code finder agent. It has a really simple base prompt in here. And when someone makes a pull request, all I have to do is just type in this command. It's going to kick off a GitHub event that comes into my system, and then it's going to run Claude Code or whatever agent that I want. I think in this case, this agent is running, actually, I don't know what this agent's running. I guess it depends on the trigger. So if I go to the trigger and edit it, this is running a Claude Code instance with that prompt and also some additional prompting to basically grab the pull request, do some reviews over it, and then leave comments on the pull request. But the idea is I'm trying to make this as generic as possible so you can literally make agents that do anything over your code, or you can kick off a swarm of agents, which I'll demo in a second. And as you can tell here, it did a security audit on the changes of this pull request, and it kind of leaves a summary at the end to say, hey, this one could use a little bit of changes, but overall it's like a 4 out of 5. I could merge it if I want to, but there are some things that it does recommend that it gets changed. Now, again, this was all for fun and for me just to challenge myself building something larger, but I do want to demo this out because behind the scenes, this is actually scaling out a bunch of EC2 instances, and on them it's running Firecracker micro VMs to do all the work in isolation so that in the future, if I do decide to open this up as a paid platform with multi-tenant support, all these jobs can run in isolation and not potentially cause issues. So let's do a quick little kickoff. And I do want to state that the point of this video is to walk you through a diagram of how this is all kind of architected. Because again, that's the point of this channel. I want to talk about higher level architecture stuff instead of just making hype videos about AI. So one example, let's go to my agents. I do have a code cleaner agent. So this is basically going to say clone a GitHub repo URL, inspect the code base for one small cleanup opportunity, look for things like magic numbers, vagues, names, etc., duplicate logic. Basically, it's an agent that'll go and clean up code. And then it makes a pull request with the changes, which will then get inserted into the repo. So let's actually kick this off, and I'm going to do this in a swarm. So let's go to swarm. I'm going to say run swarm. I'm going to select that code cleaner agent, and then we are going to go ahead and just run it in, let's just do Composer 2.5 right now. It's a pretty fast model. And then we are going to enable the swarm, and we're going to have this do, let's say 20 different agents. So 20 agents that are going to run. We should have 20 PRs at the end of this. And then at the end, I will just go ahead and paste in that GitHub URL that was a required parameter. So now when I kick this off, what's happening behind the scenes is it kicks off a bunch of events into a queue. In this queue, there's a Lambda that's listening to basically auto scale a bunch of EC2 instances to handle doing all this work. So in this case, I did 20. I think I can get about 3 micro VMs running on each of these instances. So 3 times 4 would give you what? 12. I probably need a couple more. Okay, so these are also scaling up as well. Now, eventually all these will come online, and I will say that the boot time, the cold starts are a little slow for EC2 instances, but overall it doesn't matter because like this isn't something I need done like right now. I just need to scale up and then scale back down when I'm done, so it saves me some money. If I wanted this to be more instantaneous, I could just set a min value for this auto scaling group so that I always have a bunch of hot instances, but I'm going to be charged for that, right? So at some point, these will come online and they're going to start pulling off that queue and then start kind of running these prompts inside of Claude Code. Now, you might think that all these jobs will kind of like step on each other's toes, and I will state that I have a built-in shared memory system. So I basically inject a system prompt into whatever the agent harness is, and I tell it, hey, before you actually do the work on mission control, I want you to go off and try to claim the work. So I don't want 3 or 4 of the exact same tasks trying to fix the exact same code. I'd rather them kind of be self-aware what's going on and self-coordinate so that there's no overlap in terms of the work. So this one's actually running off right now. I have logs that automatically stream in to these different swarm agents, so you can kind of watch the logs. At some point, these will all finish, and then they can generate artifacts if you want. So like if you wanted a agent to generate text files or images, at the very end, the host agent on the EC2 instances will grab the artifacts from the micro VM and upload those to S3, which will show up over here. But that's kind of the idea. So now we have a bunch of EC2 instances that are running micro VM, Firecracker, Sandboxes, and those are running cursor inside of them with my system prompts. And eventually, I should see a bunch of pull requests get opened up to mission control. I'm going to go ahead and just wait a little bit, and I'll come back, and we can show that. All right, so as you can tell on this page, as these jobs are finishing, this page is updating. We actually have WebSocket events that automatically update all the user interfaces here. So if there's logs that you're trying to watch, these will automatically just update like I kind of mentioned. Let's go to logs. These are going to get streamed in as cursor is finishing. Oh, it just completed. And eventually we get all these pull requests that are open that I can then go through and just review and merge in if I want to. Or I can kick off another swarm to triage all these and just merge them in for me. So the idea of this platform is to allow a developer, or who knows, in the future, this could be extracted to anyone, to build out agents, to configure them to do different things. You can have these run on schedules. So that's kind of what I'm building out. I've been having fun building this. I will say that, a task like this, spin up 20 different EC2 instances to clean up code. You could do this in a simple like Claude code with a dynamic workflow. You don't need to do this. I'm just trying to demo the power of like, you run a command in a swarm, it spins up all these EC2 instances. And by the time I'm done talking about what I'm going to talk about with the diagramming, you'll notice all these scale back down to 0. So it doesn't cost me anything. These are like 9 cents an hour to run. So it's really not costing me much money to do that type of work. But I could kick off a bunch of different jobs to actually do real work, add new implementations, fix bugs, etc. All right, so let's talk about how this works. So in the UI that you just saw, just go ahead and say like browser. This is I'll call this the dashboard. So in the dashboard, I'm kicking off a job, and that job is going to go to a control plane. So control plane is what I'm calling it. And we're going to go ahead and just do this. So we kicked off a job to the control plane. What happens is the control plane is going to obviously check authentication, make sure you are who you say you are, and that is going to store a record into Dynamo. So if I get a database here, we can say DynamoDB, and that's going to store a record for that job. So that's kind of what's allowing us to go back and look at all the jobs that we have. It's just storing a record in DynamoDB. Nothing special about that. But the interesting part is we also have a queue. So if I bring up a queue over here, the control plane, after it's confirmed that it stored the job, it's going to go ahead and just insert a record into this queue. So I'll say store event in queue. Step 2 is create job record. And this is run job. Or in this case, it was a swarm, right? I said a swarm of 20, but again, that's just 20 jobs behind the scenes. So as I'm pushing to this SQS queue, we actually have another Lambda. Let's see if I can find like a Lambda function. All right. We have a Lambda function that is basically inspecting the queue depth. Okay. So I'm going to say queue depth. How many events are in this queue? And it also knows how many EC2 instances I have up. So there's also some information about, okay, let's check out how many EC2 instances I have up. I do believe that's coming from DynamoDB. So I'm going to say check EC2 support. Okay. So this checks how many EC2 instances do we have? Do we have enough instances spun up to even handle processing all these events? So if not, we have an auto scaling group configuration, which kind of tells AWS how many EC2 instances you want in a pool. So the Lambda basically configures, I'll say configures auto scaling group, and that auto scaling group is going to control basically a bunch of EC2 instances. So I'll just go ahead and put some boxes. These could be my EC2 instances. But inside of these EC2 instances, when it spins up, I do have a baked AMI that has a Rust, I'll call it an executor. And this executor is what's going to be listening for these queues. So I'm going to go ahead and let's just simplify this a little bit so we don't get so confused, but just know that this is going to scale up based on how many messages we have. The executor is going to pull events from this queue. And it does have some like claim logic in Dynamo to make sure we don't accidentally pull the same event twice, because SQS is, I think it's at least once delivery. So you can have multiple deliveries to the same thing. Or if you have multiple of these instances running concurrently, they could both potentially pull the same event, right? So we have this Rust executor. It's pulling SQS events. And what this does is it's going to spin up a Firecracker VM. So Firecracker VM. The Rust executor is going to run that. And it's going to provide a couple of things. So there are some shared volume mounts that are happening so that the VM can actually pull in some secrets. I do have secrets that are stored. If you notice in my jobs, if you go to secrets, I have the ability to set up secrets. So how exactly is this working? So inside of Dynamo, we have some secrets, but in order for this Firecracker VM to run those, we have to somehow get those secrets that the user configured to the box, right? And so what happens is inside this SQS event, there is a one-time token that I'm basically setting up. So send event, there's a one-time token, which this Rust executor can use to basically fetch from the control plane. It's getting a little bit confusing over here. So from the control plane, we can fetch back and say, hey, here is my token, give me secrets. And that token is scoped to only give back the secrets that are related to that particular, you can see there's like different presets here. It's only going to give back these 3 secrets. So you can actually have this more like fine grained. If you have different projects or different jobs you want to run that shouldn't have access to other secrets, that's kind of how that works. So we're going to give back a token, which gives us the secrets, but also I do have some GitHub connections going on over here. So like we have to also ask the control plane to give us a 1-hour token so that after I do like the whole GitHub connection over here, if I connect my GitHub account, it can actually get access to the repo using the GitHub app approach. Okay, so I do have GitHub app set up that's allowing it to basically create a 1-hour token. So that's also something that it gets back from the control plane, which it then provides it to the Firecracker VM. So inside of here, there are like the secrets that get passed inside of like a simple little secrets file. So this will basically be some initial secret file. And then also I do believe it has like some other assets you could pass in. Like if you want skill files or something to run in your Claude Code agent, you can do that. And that is just basically a shared volume mount that only this Firecracker VM has access to. So of course, inside the micro VM, there is your Claude Code instance or your cursor instance or whatever that has access to these secrets, has access to your assets. It's going to run whatever prompt you gave it. And then eventually that is going to store its assets back into like a shared volume that only this VM has access to. The Rust executor, when this whole thing is done, it's going to grab those assets, and with a pre-signed post, it's going to put them back into S3. Let's make a bucket over here. It's going to put those inside of S3, which again, the control plane and the dashboard has access to kind of download if you want to. So we can just go ahead and put this. We'll say this is the assets bucket. And then eventually when this is done, this will just go ahead and like clear up. And it also deletes all the additional stuff that we stored on disk to clean that up. And then the Rust executor will kind of phone home back to Dynamo and say, hey, this thing is done. This job is done. It's completed. This is how long it took. Actually, I will say, I don't think the Rust executor actually talks to Dynamo. I think it talks directly to the control plane. The control plane is what tracks like how long that run took, so that we can then go and update the compute usage of that. And then at some point when the queue depth is low again, this auto scaling Lambda is going to basically just scale this thing back down to no EC2 instances, delete the Rust executor. And if we go back to AWS, notice here that we have no instances anymore. It's cleaned up. I'm not getting charged for having those things run around. So that's kind of how it works. There's a lot of stuff I didn't touch on, and there's a lot of things I can go more into depth on if you guys want me to. I do think just making some cool videos talking about this platform I'm building out could be very useful for learning. So yeah, let me know if there's anything else you want me to dive into. There's also like a Reaper Lambda. So like over here, there's a Lambda that runs periodically using Event Bridge to basically go through, because I was actually going through and like manually deleting instances that just, you know, try to speed up the saving on money aspect. But because I did that, the actual executor on the EC2 instance never phoned home to say, hey, the job is done, which means I have a bunch of like stale Dynamo records laying around, and the auto scaling group still thought that these jobs need access, right? So there's like a Reaper process that goes through and just cleans up old stale jobs so that the auto scaling group can properly scale back down. Yeah, honestly, I could probably make a whole video about the whole Firecracker VM and the EC2 instance and how that's all set up. It's pretty complex, and I honestly need to dive more into the details of that before I even consider making this thing public, because there's a lot of security concerns having these multi-tenant VMs running inside of EC2 instances that you definitely want to make sure the security is locked down on that. But anyway, yeah, let me know if there's anything else you want me to kind of dive in on. I wanted to share this with you all because I thought it was pretty cool. I enjoyed building this out. Of course, I use Claude Code and Fable to build a lot of this stuff out, but I'm asking questions every step of the way. I am basically guiding it to use the AWS services I would want to use to build this out. And who knows, maybe I'll actually make this into a real product soon. All right, have a good day and happy coding.